See if the audio is coming through. Check. Just checking the sound is good. Then we'll start off. Just checking the sound is good. Yep, all good. Oops. Let's set a timer as well. 2 hours. Whoosh. Put that there. Right, so welcome peeps. This is the beginning of the journey for Boot.dev. Said I was going to do it. My aim is to complete it in the year. So I paid for a year. Thanks to Primogen for his New Year sort of deal off. That was really useful, so I saved a little bit of money on that. And yeah, I guess we're kind of just going to get started. Hope you enjoy watching and learn something along with me. Maybe you can make use of the same discount and getting on the action and stuff. I'm doing this because really I just want to kind of get into back-end development again more seriously. Just kind of build like a deeper understanding of especially things around like, algorithms and data structures, stuff like that. I just want to kind of practice the fundamentals, as it were. So yeah, we're going to cover all of this and stuff, and then hopefully this will lead us on to building some of our first things with Go, like and whatnot. So let's get cracking. So we're going to enter the course. In fact, let me just check. That's the first one. I'm pretty sure it's the first one. Yeah, start your next course. So enter this one. There's 30 hours of content, 189 addicting lessons. A certificate of completion learned online at your pace. Lane Wagner. Shout out to everybody at Boot.dev. Thanks for making an amazing resource. I'm sure it's going to be absolutely awesome. Let's get started. So let me see how the window is set up for this. Not too bad. I might have to maybe make a smaller version of me at some point so you can like see everything that's going on. Or I have to get some like green screen going on so it just cuts my face out and not everything else. But anyway, for now, I just have to kind of like run with it. So welcome to Learn Python, the best first programming language. I only know a little bit of Python, so it's going to be good to go through this and build a really good fundamentals around it. How to run code on Boot.dev. The greyish bluish run button runs your code. The gold submit button runs your code and submits it to check your work. The right arrow will take you to the next lesson. I can see the right arrow up there. Building Fantasy Quest. We're going to build a text-based adventure game called Fantasy Quest in this course. I've written the first line of code for you. It prints the message below the editor welcoming new players to the game. Submit the code to pass the assignment and click right to continue. So submit. Woo-doo! Nice. And then we can continue. Fix your first bug. The combat system in Fantasy Quest isn't working as intended. It appears that players are gaining health when attacked instead of losing it. Fix the math bug on line 3. So line 3, health after attack. Let's change this to a minus. Run. Submit. Boosh. Easy peasy. And I didn't actually check about this and stuff. So unlock spellbooks for completing lessons. Struggle I, the Boot's efficiency bubble sorter. I'm happy to help. Ask me anything about the lesson if you find it, my explanation suspect. Ask a human on Discord. That's cool. So can I ask for help if I get stuck? Which probably will at some point. So the console is the panel that displays important messages like errors or the text output of a program. If we want to see what's happening in our code, we need to print it to the console using the print function. We'll learn more about functions later, but for now, just know that print function will print anything you put in the parentheses. For example, this assignment. We need you to tell new players how to move. Print the following text to the console. So we say print. Has it got any tabbable? Use single quotes. Yes, you can. Huzzah! Very nice. So we've got a what is Python?
According to Stack Overflow, we think Python.
Oh,
according to
right, I'm gonna have to get my headphones to this, aren't I? So, one moment. Just check that the sound's working properly.
Stack Overflow and
Yeah,
their methods
working.
of slicing the data, Python's actually among the most popular programming languages in the world. We think Python is one of the best programming languages for you to start with if you're learning to code for the first time. It's easy to use, but it still gives you plenty of control to build almost any kind of application. If you're new to programming, it may not seem like it right now, but Python code kind of reads like plain English, at least compared to the seemingly cryptic syntax of some other programming languages. Python is used all across the programming industry in backend web development, automation, machine learning, DevOps, and cloud engineering. Once you've learned one programming language, almost all the concepts you learn will also apply to other programming languages. So making a switch in technologies just isn't as big of a deal as we make it out to be. Learning a second programming language isn't nearly as hard as learning a second natural language like Spanish or Japanese. Anyways, best of luck, and if you have any questions, join us in the Discord and ask away.
Nice video. Hundreds of thousands of students start their coding journey right here with Python. Python doesn't have to be your first language, but I think it's the best first language for most developers. It gets out of your way so you can focus on learning fundamental programming concepts. But just because Python is simple doesn't mean it's not useful. Python is an extremely popular language in the industry. It's well known for backend web services, DevOps and cloud engineering, machine learning, script and automation. On the other hand, it's not particularly well known for front-end development. While it's possible to do so, Python isn't typically used to build interfaces. So here's a question. We click the answer. It's not popular. It's not often used for front-end apps. Explain why? Let's have a little look at this. Ah, fine question indeed. Let's unravel it together. The question says Python is not often used in. This means you're being asked to identify the area where Python is less commonly used compared to others. Now let's walk through the options. So the front-end apps, we already know this one. So while Python can technically be used for alright, okay. It's just a explanation of the answer, not really much else on it. Okay. What is Python?
According to Stack Overflow and their methods of slicing the data, Python's actually among the most popular programming languages in the world. We think Python is one of the best programming languages for you to start with if you're learning to code for the first time. It's easy to use, but it still gives you plenty of control to build almost any kind of application. If you're new to programming, it may not.
That's the same one. So, what is code? Code is just a series of instructions for a computer to follow one after another. Programs can have a lot of instructions. The Boot.dev backend has 46,119 lines of code as I write this, and it's much smaller than some of the projects I've worked on. Remember how we used print instruction to print text to the console? You can also use it to print numbers. This prints the number 42. Well, addition is one of the most common instructions in programming. This also prints the number 42. It first calculates the sum inside the parentheses and then prints the result. Assignment, simple addition is used all the time in game development. In Fantasy Quest, we want weapons to deal bonus damage when they're enchanted. Our hero sword deals 250 damage normally, but should deal additional 75 damage when it's enchanted. Calculate the printed result of 250 plus 75. 50 plus 75. Submit that. Whoosh! 322. All easy stuff at the minute. Multiple instructions. Code runs in order starting at the top of the program. For example, print. This prints first, this prints second, this prints last. Each print instruction prints on a new line. Assignment. The dialogue in our game should display in the correct order. In the first level, our hero encounters a talking owl named Jax. Run, not submit, the code and see why it's printed, that it's printed in the wrong order. Rearrange the code so it prints in the following correct order. So yeah, it's like that. So we want Jax Bakar. Hero, and then that's fine. So like that. Ta-da! Syntax errors. Syntax is a jargon for valid code that the computer can understand. For example, the following code is invalid syntax. Print hello world. It has mismatched quotes around the string hello world. One is single quote, the other one is double quote. Assignment. Let's continue our work on Fantasy Quest. There's a bug in our game and our players are distraught. They're so needy. It's not like we added microtransactions. The code was supposed to print "Welcome to Fantasy Quest" to our users, but they get an error instead. Find the syntax error in the code and fix it. Well, there's a quest to our users. Oh, bracket. Couldn't see that. Syntax errors quiz. Syntax. The rules of how the rules for how expressions and statements should be structured in a language. For example, in Python, the following is correct syntax. This, while in a different programming language like Go, the correct syntax would be fmt.println hello world. Syntax errors aren't the only kind of problems you can run into when coding. For example, a bug in your logic. Your code is valid and will run, but it does something unexpected. It's too slow. Your code is valid and does what's expected, but it does it slowly. In this course, we're just concerned with syntax and logic errors. We'll cover performance issues in a later course. What does syntax mean? So the rules for valid code in a programming language. Yeah, this one. Yay! We're just going to smash through these ones really quickly. Syntax error quiz. Syntax, the rules for how expressions and statements should be structured in a language. For example, in Python, the following is correct syntax. This, while in a different programming language, it's just asking the same things again. So what happens if you try to run code with invalid syntax? Your dreams will either wither and die alongside the last few hopes and aspirations. You'll get an error message from Python interpreter and the code won't execute. That one. Booyah. Lesson failure. You probably noticed that you have a submit and a run button. Run for testing and debugging. There is no penalty for running your code. Submit runs your code but also checks its output against the our answer key. If the output doesn't match, you'll be punished. Pro tip: you wouldn't deploy code to end users without testing right, so don't submit code without running it first. The goal of this game mechanic is to encourage good real-world coding practices. Submit is like deploying to production. What's the penalty? When you fail a lesson, you get one of two things will happen. If you have armor, you'll lose one. That armor is consumed to protect you from future failures on that lesson. If you don't have armor, you'll lose your sharpshooter spree and it will reset to 0. Each time your spree counter hits 15, you'll earn a random chest. Chest contains gems and items like armor. Assignment. Fantasy Quest has a bug in its server code. The code is supposed to print messages indicating the game server has started successfully. Fix both syntax errors in the code. So this one immediately is a double quotes issue, and this is just spelled wrong. We'll run it, and then we'll submit it. Boosh. This is an optional challenge. You can skip to the next chapter if you want. Well, we'll just do it. 1 second. Nice and toasty in here already, so. Oh. Game statistics. Our team is asking for some stats on our Fantasy Quest game servers. They'd like to know the average number of players on the 4 servers. Simon. Debug the code so it correctly prints the solution to the math problem. Remember, print just prints the text in quotes. If you want to print the result of a math expression, you can't put it in quotes. So obviously, what I do is just take away the quotes. Run. That's it. Whooshka. This is an optional challenge, okay. Shop response. Our dev team has been making updates to Fantasy Quest's Innkeeper's shop. But there's a problem. The Innkeeper's text dialog is empty. Add 2 separate print statements to complete the Innkeeper's response. They should be the following. Captures on. Easy peas. So variables. How do I check, like, so okay. Chapters. Okay. We might get through this quite quick. Well, we'll see. We'll see. Quite a lot of steps actually, so maybe we might not. Anyway, we digress. So variables. Variables are how we store data as our program runs. Up till now, we've been printing data by passing it straight into the print. Now we're going to save data in variables so we can reuse it and change it before printing it. Creating variables. A variable is just a name that we give a value to a value. For example, we can make a new variable named my height and set its value to 100. My height, like that. Or we can define a variable called my name and set it to string text string lane. We have freedom to choose any name for our variables, but they should be descriptive and consist of a single token, meaning continuous text with underscores separating the words. Using variables. Once we have a variable, we can access its value by using its name. For example, this will print 100, this will print lane. We need to keep track of our hero's health. On the first line of code, create a new variable called player health and set it equal to 1000. So, columns. Wishka. Easy. Variables vary. Variables are called variables because they can hold any value and that value can change. It varies. For example, this code prints 20. The line acceleration equals 20 reassigns the value of acceleration to 20. It overwrites whatever was being held in the acceleration variable before 10 in this case. Assignment. We need to reduce our hero's health as they take damage. Before each print function in the provided code, change the value of the player health to 100 less than it was before. The final output should look like this. 900, 800, 700, 600, so reduce by 100 here, so I'm going to do that. Equals 900. That equals 800. That equals 700. And this equals 600. Run. Submit. Easy. Just get rid of these for now. Not really too bad about the rewards and things. Storing results. Now that we know how to store and change the value of variables, let's do some math. Here are some examples of common mathematical operators in Python syntax. Addition, subtraction, multiplication, and division. Parentheses can be used to order math operations. Assignment. Create a new variable called armored health on line 4 and say equal to player health multiplied by armor multiplier. So create armored health here. So armored just call health equals player health times armor multiplier. $2,000. Bingo. Negative numbers. Negative numbers in Python work the way you probably expect, just add a minus sign. Assignment. My negative number is -1. When our hero walks through poison, their health should go down. Right now, the hero is gaining 10 health instead of losing 10 health. Change the poison damage variable to be negative. So poison damage is going to be negative. So when you plus them together, it just works. Bingo, bingo. Comments. Comments don't do anything. They're ignored by the Python interpreter. That said, they're good for what the name implies, adding comments to your code in plain English or whatever language you speak. Single line comment. A single hash makes the rest of the line a comment. Multi-line comments, aka docstrings. You can use triple quotes to start and end multi-line comments as well. This is useful if you don't want to add a hash to the start of each line when writing paragraphs of comments. Assignment. Line 1 in the code was meant to be a comment, but the developer got to use the correct syntax of hash. Yeah. Variable names cannot have spaces. They're continuous strings of characters. Creative Python language himself, Guido van Rossum, implores us to use snake case for variable names. Why is snake case? It's just a style for writing variable names. Here are some examples of different casing. So snake case, all words are lowercase and separated by underscores. This is recommended by Ruby, Python, and Rust. Camel case, capitalize the first letter of each word except the first one. My hero health. This is thinking by JavaScript and Java. Pascal case, capitalize the first letter of each word. My hero health, C# and C++. No casing, all lowercase, no separation. My hero health, no one. Don't do this. To be clear, your Python codes could still work with camel case or Pascal, but please can we please just have nice things? We just want some consistency in our craft. If you won't use snake case for you, do it for me, I beg you. Which is valid camel case. That one. But yeah. Variable names. Oh, okay, there's another one. So which is variable snake case? That one. But yeah. Basic variable types. Python has 7 basic data types. Strings. In programming, snippets of text are called strings. They're a list of characters strung together. We create strings by wrapping the text in single quotes or double quotes. That said, double quotes are preferred. Not so good. So good. Numbers. Numbers are not surrounded by quotes. They are declared. They're declared. An integer is a number without a decimal part. positive integer, negative integer. A float is a number with a decimal part. Booleans. A boolean or bool is a type that can only have one or two values, true or false. As you may have heard, computers really only use ones and zeros. These ones and zeros are just true and false boolean values. So is tall, true is short, false. Assignment, fix the bugs in the code. Player health should be an integer and player has magic should be a boolean. Let's take away the quotes. Let's go. F strings in Python. Ever played Pokemon and chosen a funny name so that the in-game messages would come out funny? America's strength made it possible to move boulders around. Very good. In Python, we can create strings that contain dynamic values with the F string. Ooh, F string. With the F string. Whoops. Num equals 10. F string. F, you have bananas. Print F string, you have 10 bananas. Basically like template interpolation JavaScript. Opening quotes must be preceded by an F. Variables within curly brackets have their values interpolated, injected into the string. It's just a string with a special syntax. Assignment, fix the bug on line 7. Use an F string to inject the dynamic values into the string. Replace name with the value of name variable. Replace race with the value of race variable. Replace age with the value of age variable. Do not hard code the values into the string. For example, this is not a solution we're looking for, even though it happens to work in this case. Jarl is a dwarf who's 37 years old. We need the player to see their values. Punctuation matters. Make sure your output matches the expected output. Exactly. Awesome. F at the beginning. And that was it, wasn't it? And the things is just curly brackets. So what was the start? Name. And then this part was going to be race. This part was going to be age. And I'm confident I'm just going to submit. Boosh. Like living on the edge. Non-type variables. Not all variables have a value. We can make an empty variable by setting it to none. None is a special value in Python that represents the absence of a value. It is not the same as 0, false, or an empty string. So my mental acuity equals none. Very cute. The value of mental acuity in this case is none until we use the assignment operator equals to give it a value. None is not a string. Non-type is not the same as a string with the value of none. This is non-type, this is string with the value of none. Assignment, declare a variable named enemy and set it to none. Don't change the print function. So enemy equals Bushka. So enemy is none. Non-type quiz. How many things we got? We've got 14 chapters we could smash through all over today. Feeling it. We're going to get through this in a year. We got to smash this out. Okay, non-type quiz.
The non-type in Python is weird, and discovering it in Python is probably really mind-bending in the same way that discovering the concept of 0 would have been mind-bending to the ancient Sumerians. Let's start with an example. I'll create this variable age selection and set it equal to none, and that's none with a capital N. It's important to note this is not the same thing as the string none, which would be surrounded in double quotes. None is its own special keyword in Python. It's not just another string. For example, hello world is a string, 1 is an integer, false is a boolean, and none is actually of the type none type, which is its own special categorization. Strings and integers both have infinite possibilities of what they could be. There's an infinite number of strings that you could store in a string type or integers that you could store in an integer type. A boolean can only be true or false, but the none type can actually only contain the value none. So why is this even useful? Well, the idea of none is to communicate that there's nothing here, and not just the value 0, because sometimes 0 means something. Again, let's go back to our example of a variable called age selection. Let's say we have a form on our website where you can input an age. Well, inputting the age 0 would actually be a valid selection. So we can't use 0 to represent the state where the user has not yet selected an age. Again, because you could select 0. So one common use case with the none type is to sort of use it as a default value for a variable. And it indicates that, nothing is stored here yet, but there likely will be or can be in the future. Now, one common mistake I see with new Python developers is when they print a value, or I should say when they print a variable that stores the none value, it will actually print the string none to the console. And that's confusing because if you write a program that instead of printing a variable that stores the none type actually prints a string that just says none, the exact same thing is printed to the console, but they're not the same. Now, the easiest way to test is to actually wrap the variable in a type function. So you're actually printing the type of the thing. And in that case, you'd get a message saying, this is a none type or this is a string type. So if you ever get stuck or lost and you're not sure what you're looking at, be sure to use that in your print debugging.
Indeed. As we mentioned in the last exercise, the none keyword is used to define an empty variable. So when would you use it? One use case is to represent that a value hasn't been determined yet. For example, an uncaptured input. For example, your program is waiting for a user to input their name. You might start with a variable username none. Then later in the code, once the user has entered their name, you can assign username to the variable. Remember, it's crucial to recognize that none is not the same as none. Yeah, we've been through that, okay? So why might you use non-value? To create bugs, absolutely. No, to cause additional pain and suffering to your co-workers. It's always nice. Because you need a string with the text in none as the default value in place later. Yay! I don't hear any sound. Is there any popping sounds when this does that? That'd be nice. Like these notifications. Thank you. Dynamic typing. Python is a dynamically typed, which means a variable can store any type, and that type can change. For example, if I make a number variable, I can later change that variable to a string. But maybe don't. It's in almost all circumstances a bad idea to change the type of a variable. The proper thing to do is just create a new one. For example, speed is 5. Speed description is 5. What is non-dynamic typing? Languages that aren't dynamically typed are statically typed, such as Go, which you'll learn later in a later course. In the statically typed language, if you try to assign a value to a variable of the wrong type, an error would crash the program. If Python was statically typed, the first example from before would crash on the second line, speed equals 5 in the string. The computer would give an error and the lines, you can't assign string value 5 to a number variable speed.
It feels like everywhere I look, people are talking about types. If you're just getting started learning to code, you've probably heard of JavaScript, TypeScript, and Python. Well, they all have a different approach to how they type their variables. In this video, we're going to quickly break down the difference between static and dynamic typing and talk about how different languages use these different approaches. And at the end, I'll break down for you which approach I think is better. I teach a lot of Python code, so let's start with how Python approaches typing. Python is a dynamically typed language. So when you create a variable in Python, let's say x, and you set it to a value of, say, the number 5, that variable x happens to store an integer type. But at any point in the program, we can change the type that x stores, right? We could change it to, say, the string 5. Many scripting languages tend to be dynamically typed, right? Languages like Python, JavaScript, Ruby, and PHP. And the reason is when we don't have to specify types as we're writing our code, we're able to write the code a little more quickly. Now let's take a look at how Go, a statically typed language, approaches this same problem. So in Go, we might write something like var for variable, x is an integer, We set it equal to 5. So this is a little more verbose, but we're being explicit and we're saying this variable x is an integer. Now, what happens if later in our program we type x equals the string 5? Well, what happens is our program completely breaks. Go as a language, or TypeScript or C++ or one of these statically typed languages, does not allow us to change the type of a variable. Once the type has been set, we need to keep the values stored within that variable of that same type. So the question is, which approach is better? Well, if you had asked me 10 years ago, I may have said that there is a trade-off here, maybe a fairly balanced trade-off, and that the languages like Python, JavaScript, Ruby, and PHP, they chose this way of doing things because it's syntactically simpler, right? We don't have to type nearly as much to get our program up and running. So if we're just writing really small scripts, then this dynamic typing seems to be a huge advantage, right? We can move faster, we can write code faster. When you're working on larger systems, though, the advice has always been static typing is better. And the reason being, it results in fewer bugs. There's basically never a case where you want to take a variable, say player name, and change it from, say, a string to an integer. That doesn't make sense. You would just create a new variable. So by having a set of tooling that doesn't allow you to accidentally change your types tends to result in less bugs and more readable code. So the trade-off seems to be, with dynamic typing, we get to kind of write less code to do the same amount of work, but that code can be more buggy and harder to read, harder to maintain. Or we can write statically typed code, which is less prone to bugs, but takes a little longer to write. It's a little more verbose. Now, that trade-off used to be the case, but these days, I'd argue that static typing is simply better. And that's because newer languages like TypeScript and Go and Rust, they have a thing called type inference. And type inference basically gives us the best of both worlds. It allows us to have static typing, but with a very simple syntax. So for example, in Go, rather than using this verbose syntax here, I could just write x equals 5. And by doing that, the computer knows that x is an integer. It can infer that type from its initial value. And then later, if I try to change x to the string 5, again, the same thing happens. That's not allowed. Older statically typed languages, things like Java, C, C++, they didn't have type inference back in the day. And so this trade-off really did exist, right? But these days we can have the best of both worlds with type inference. So you might be wondering, if static typing is so great, why do you teach Python on Boot.dev, right? Why don't you just teach the static languages if they're so much better? Even though Python is dynamically typed, it's still an amazing language. I love starting students on Python because it's easy to write and it's easy to learn all of the basic programming concepts in a language like Python. But Python isn't just a toy language for learning to code. It's used by thousands of companies in production, and it remains one of the most popular programming languages out there. I use Python day to day for scripting on my local machine and doing little tasks that are kind of one-off and simple. Toward the end of the backend developer career path on Boot.dev, I start teaching students Go. And one of the main reasons for that is Go is a statically typed language. It's easier to build large, production, kind of robust backend systems in a language like Go. At least that's my opinion. But you can build large production backend systems in statically typed or dynamically typed languages. It's certainly been done both ways. Hopefully this video has helped you out in understanding the difference between statically and dynamically typed languages. Please do like and subscribe if you enjoyed it.
I would, but we're not on YouTube right now. It's good video explaining that. Enjoyed that. Okay, so dynamic typing. This is the same page as before, same video and stuff. So what kind of typing does a Python employ? Dynamic. Whee! Okay, math with strings. When working with strings, the plus operator performs a concatenation, which is a fancy word that means joining two strings. Generally speaking, it's better to use string interpolation with F strings over concatenation. Lane Wagner, first name and last name, Lane Wagner. Print full name, Lane Wagner. Oh, excuse me. Full name now holds the value of Lane Wagner. Notice the extra space at the end of the lane at the first name variable, that the extra space is to separate the words in the final result Lane and Wagner. Assignment. We have a second player in our game. We need to tell each of our players how much health they have left. Edit line 9 to print player 1's health. You have 1,200 health left using string concatenation and the variables provided. Don't edit the above lines. Okay, if you say so. Okay, so you string concatenation, so it's sentence start. Edit to print in the same way. Sentence start, you have player 1 health plus sentence. Keep spelling sentence wrong. Sentence end. Edit line 10 to print player 2's health. You have 110 less. So sentence start plus player 1. Oops. Player 2 health plus sentence end. But a bishko. Only print you have X health once for each player, nothing else. Ta-da! Multi-variable declaration. We can save space when creating many new variables by declaring them on the same line. So sword name, sword damage, sword length equals Excalibur 10 and 200, which is the same as these ones. Any number of variables can be declared on the same line, and variables declared on the same line should be related to one another in some way so the code remains easy to understand. We call code that's easy to understand clean code. I have heard of that before. How many variables can be declared on the same line? No limit. It's kind of crazy. You could have all sorts of shenanigans going on there. Why is clean code? Code that runs quickly? Absolutely. Nope. Code that is easy for developers to read and understand. Always. Although, it's a little subjective. Crikey. Boots. You may have already figured this out by now, but below the lesson explanation or the Boots tab on mobile, there's an adorable bear wizard named Boots. Yeah, I spotted him. He's really cute. His job is to help you when you get stuck. Here's how. Boots is an AI chatbot like ChatGPT that's been trained on our lessons. When you ask him a question, he already knows the official solution, what you've been asked to do, current state of your code. If you press the clipboard button to paste, if you press the clipboard button to paste it in, where's the clipboard button? Reset lesson, question, oops, spellbook. Where's the? Oh, that one. Base code. He's been trained to not give you the answer that's bad for learning, but instead use the Socratic method to help you figure it out. He asks you to follow up questions and explains fundamental concepts to keep you moving forward. Chatting with Boots before you completed a lesson cost a baked salmon. He's a hungry guy. Or if you don't have any, where do I have baked salmon? I got no embers. I got no frozen flames. I'm on difficulty 9. I don't really know what that means. I got a spree. I don't see any frozen salmon though. Baked salmon. Whoopsie. If you don't have 150% of the XP that you've earned from completing the lesson, you only need to pay once per lesson to start the conversation. Let's pay once for. All right. Chatting with Boots after you complete the lesson is free. Use this to ask follow-up questions, review the concepts, or ask more for more examples. The assignment. Fantasy Quest dialogue messages are all jumbled up. Fix it. Run the code. Notice that nothing prints to the console. Ask Boots why nothing is printing. You don't need to pay up. Just do it. Be sure to click the clipboard icon next to the text to input to include your code so you can see it. Use Boots to figure out what's wrong. Fix the code, then submit it. We're expecting the following output. Okay, so we'll use the thing. So run the code, notice that no prints in the console. With Run the code. Ask Boots why anything is printing. Why? Something. Do you want to ask Boots a question? Make sure... yeah, that's fine. I see the issue, young adventurer. Your code has all the variables defined with the quest text, but you haven't told Python to actually display anything yet. I wonder what kind of voice like Boot's going to have. In Python, to display text to the console, we need to use print function. Without any print statements, Python will silently run the code but won't show you any output. Let's think about this. How would you print the first line? Quest start. What about the second line? Quest middle. For the last line, you'll need to combine quest end and quest objective with a space in between them. How might you use that using the space variable? Would you like to try adding some print statements to display text of the quest? Absolutely, Boots. What a great idea. So it says don't touch above this line. Okay, all right then. And what do we say the output needs to be? So it says, you there, adventurer. So print. Or is it quest start print? The local mine has been taken over by orcs. Quest middle print. And it says we need your help taking it back. So we're gonna need quest end plus space plus quest objective. Let's run it. It works. Huzzah. Bushka. Na-na. Thank you, Boots. You're welcome, my young lad. I'm not young anymore, Boots, but thank you. Spellbook. As you progress through Boot.dev, you might find yourself wanting to take notes, review concepts you've already learned, see more examples of a concept, see an example of some syntax you've already learned. Your spellbook solves these problems. Just an encyclopedia of things. It's a searchable cheat sheet of everything you've learned on Boot.dev. Ooh, I got some. Oh wait, no, I'm not going to yet. You automatically unlock a new page in your spellbook that can be searched anytime. So if you know what you're looking for, use your spellbook before chatting with Boots, because using the spellbook costs no items or XP. Assignment. Competitive fantasy quest players, Balance Ballers, have won all their games in the elimination round of the tournament. They're now in the finals. Calculate the average score of their 4 games and store it in the average score. The average or mean is calculated by adding up all the numbers and dividing by how many numbers there are, which means first we need to add up all the scores and divide them by 4. Let's use our spellbook to recall the syntax we need. Look at the bottom right of the text section. You'll see a toggle to switch from Boots to your spellbook. Flip the switch to open your spellbook. Search for the concept you'll need for this lesson, maybe Python math or order of preparations. Python math. Complete the lesson using a spellbook as a reference. Well, I don't need the spellbook, but it's nice to have it. Okay. So we're going to thingy this. So we're going to start brackets. Game 1 score plus game 2 score plus game 3 score plus game 4 score. And all that divided by 4. Let's run it. 100. And tell us what the answer should be, but it should be right. 100. Blimey. Okay, this is optional challenge. You can skip to the next chapter if you want. Well, we ain't skipping nothing. Yeah, we ain't skipping nothing. One of our interns started working on a program that outputs data about Fantasy Quest players' characters. It's nearly done but has various bugs. Fix the bugs and get the character report working. Update the variables to their expected data types. Name is a string. Level is an integer. Character class is a string. Windrunner. Okay, I'll just fix these other guys so I don't forget. Like so, 25. We could do that. Yeah, it does. Nice. Armor is an integer. Take away that. Magic resistance is a float. That's fine. And then account active is boolean. Fix the bug with f string on line 9. Original values. Smashing. Here we go, and submit. Huzzah! Very nice. So, we're on to chapter 3. Let's have a look what time it is. What time is it? Ooh, 9 o'clock, so we've got another hour. I think we can probably smash through a fair few of these. Yeah, just wipe the floor with it. Let's do this. Let's do this. Functions. Functions allow us to reuse and organize code. For example, say we have some code that calculates the area of a circle. Radius is 5, area is 3.14 times radius. That works. The problem is when we want to calculate the area of other circles, each with its own radius, we could just copy the code and change the variable names like this. You know what, that sounds really beautiful. That sounds perfect. Yeah, we'll just do that. That's way easier. We want to reuse our code. Why? Why would you want to redo our work? What if we wanted to calculate the area of thousands of circles? That's where functions help. Instead, we can define a new function called area of circle using the def keyword. So define area of circle, pi blah blah blah, and return that. Let's break this area of circle function down. It takes one input, aka parameter or argument called r. The body of the function is indented. This is the code that will run each time we use aka call the function. Wait, excuse me. It returns a single value of the output of the function. In this case, it's the value stored in the result variable. To call this function, fancy programmers speak for use this function. We can pass in any number as the argument. In this case, 5 for the parameter r, and capture the output into a new variable. 5 goes in as the input r. The body function runs, which stores 78.5 in the result variable. The function returns the value 78.5, which means the area circle 5 expression evaluates the 78.5. 78.5 is stored in the area variable and then printed. Because we've already defined the function, now we can use it as many times as we want with different inputs. Assignment. We need to calculate the size of a weapon's attack area. With a 1.0 meter sword, for example, a player can attack in an area of 3.14 square meters around them. You can use area of circle function to do that calculation. Fix the bug on line 13 by calling area of circle function with the spear length as input and store the result in spear area variable. Spear length. Bushko. Bararushko. Function review. Functions are tricky. It takes a minute to get used to them, but after that, they'll be second nature to you. You might find yourself slowing down a bit in this chapter, and if you do, that's totally normal.
Functions are the building blocks of real-world applications. They make it so we can reuse the code that we write, and they help us organize our code into smaller pieces so that it's all easier to keep track of. Let's take a look at this example, a function that calculates the area of a circle. It takes the radius of a circle as input, in meters, we'll be using the metric system for this example, and when it's done, it will return the area of the circle, in meters squared. Here's the code that defines the area of circle function. If all we do is define the function, it won't actually do anything. We have to call the function in order for it to execute. Let's call it with a radius of 5 as the input. Now, when the function is called, execution jumps back to the function definition. A new variable that's only available inside the function, called pi, is created with a value of 3.14. Next, we save the result of pi times r to a new variable called result. The area of a circle is pi r squared after all. Finally, we return the result from the function as its output. Execution jumps back to the function call at this point, and we capture the return value in a new variable called area. And if we want to, we can just print it. The best part is that we can then call it again with a different input, getting the associated output, and we can do it again and again and again as many times as we want.
So here's a chronological order explaining what happens in the boat of code is executed. Define area circle. The area circle function is defined for later use, but not called, except a single input and arbitrary named r. The body of the function pi equals 3.14, etc. is ignored for now. Radius equals 5. A new variable called radius is created and set to the value 5. 3. Area circle radius. The area circle function is called with the radius, in this case 5 as the input. Finally, jump back to the function definition. 4. Def area of circle r. We will now start executing the body of the function r set to 5. Pi equals 3.14. A new variable pi is created with value 3.14. Result and so on. And a return. The return variable is returned from the function as output area equals area circle radius. And the return value is stored in a new variable called area and then printed like that. Bushka. Which happens first? The function is defined on the choice of the choices, which step happens last when the code is executed. Print area. The value is returned from the function is called, the function is defined. Of the choices, which happens last? So the result of fire is calculated, function is defined, function is called, a value is returned from the function, that one. Function review. Oh, I'm still doing the same thing. Why is the variable called radius outside the function but r inside the function? Because programming is needlessly hard and makes me want to cry sometimes. Yeah, I can feel that. Because the only value of the variable is passed to the function. It is then assigned to a new variable called r, because all variables are called r inside functions. Yeah, it could be. Because all variables are automatically shortened to one letter function. Nah, it's that one. Easy weasy. So multiple parameters. Functions can have multiple parameters, parameter being a fancy word for input. For example, this subtract function accepts two parameters, a and b. The name of the parameter doesn't matter when it comes to which values will be assigned to which parameter. It's position that matters. The first parameter will become the first value that's passed in, the second parameter is the second value that's passed in, and so on. This example, the subtract function is called with a equals 5 and b equals 3. Here's an example 4 parameters. It can be called like this. We need to calculate the total damage from a combo of 3 damaging attacks. Complete the triple attack function by returning some parameters damage 1, 2, and 3. The attacks 1, attack 1 to attack 6 are already passed into triple attack functions for you, so you do not need to use them directly in the function. Okay, so triple attack, so where these combo 3 attacks, so sum of so I can just return damage 1 plus damage 2 plus damage 3. Run. Submit. Wishka. Printing versus returning. Some new developers get hung up on the difference between print and return. It can be particularly confusing when the test suite we provide simply prints the output of your functions to the console. It makes it seem like print and return are interchangeable, but they're not. Print is a function that prints a value to the console, does not return a value. Return is a keyword that ends the current function's execution, provides a value or values back to the core of the function, does not print anything to the console unless the return value is printed later. Printing to debug your code. Printing values and running your code is a great way to debug your code. You can see what values are stored in various variables, find your mistakes and fix them. Add print statements and run your code as you go. It's a great habit to get into to make sure that each line you write is doing what you expect it to do. It's the real world. In the real world, it's rare to leave print statements in your code when you're done debugging. Similarly, you need to remember to remove any print statements from your code before submitting your work here on Boot.dev, because it will interfere with the test's assignment. There's a problem with the getTitle function. It's supposed to calculate the title value and return it to the caller. Instead, it's barbarically printing the value to the console. Fix the function so it returns title instead of printing it to the console. This is easy. Return title. I did not even run that to test. I was just super confident. What are we on to? We're in chapter 3. Quite a lot in here. Oh, yeah, right, I'm just going to take a break for a second. Just check chat socials, see what's going on. A bit of brain break checking Twitter. Let's have a look what's going on. Is there no way to see like live streams on Twitter? I feel like I should be able to see it on my thing, but yeah. Oh well. I was just wondering if anyone was on the Twitter chat, but didn't matter. Let's put a poll on for people to answer. Just gonna put a poll on, see if people wanna answer it. You know, I enjoy following along at the minute. Hope so. Hope you're getting some benefit out of it. We'll we're gonna go through all this, and I think here and there, depending on like how well on track I am with like getting through Boot.dev, I'll mix up streams to do some more fun ones as well. Right, okay, back to the thing. So, where to declare functions? You probably noticed that variable needs to be declared before it's used. For example, the following doesn't work. It needs to be this way around. Code execution in order from top to bottom. So a variable needs to be created before it can be used. That means if you define a function, you can't call the function until after the definition. There's a bug. Run the code and read the printed error, then fix it. Hold on, it says right first. Okay. Easy, mix, squeezy. Bingo, bingo. Order of functions. Whoops. What happened there? Order of functions. There we go. Order of functions. All functions must be defined before they're used. I might have got left on this one. Oh, a fair few actually. Maybe I'll only get through this one tonight. Order of functions. All functions must be defined before they're used. You might think this would make structuring Python code hard because the order of the function needs to be just right. As it turns out, there's a simple trick that makes it super easy. Most Python developers solve this problem by defining all the functions in their program first. Then they call an entry point function last. That way, all the functions have been read by Python interpreter before the first one is called. Note, conventionally, this entry point function is usually called main to keep things simple and consistent. Functions must be before they can be must be defined before they can be called. Ta-da! Functions must be defined in the order that they call each other. True. Oh. Oh no, they don't. Oops. Which is best practice to make sure you don't define functions out of order? Create an entry point function usually called main and call it at the end of the file. Create a function called main, Python will always call it first. Create a function called main and call it at the beginning of the file. Create a function called entry point. That one. Put it at the end of the file. Discord. Getting help is a critical part of learning to code. And even in your day-to-day working as a developer, we've already talked about boots and spellbooks. which are great first lines of defense, but what else can you do? First, it's totally normal to look stuff up online as you work on Boot.dev. It's not cheating. It's impossible to memorize everything, and it's frankly just not necessary, even as a professional developer. Second, sometimes you just need a human. Luckily, we have an amazing Discord community full of developers and fellow students ready to help you out. So open your Discord community page, join the server and sync your account. When your account linked up, you'll be able to chat with the learners and mentors as well as use help. Additionally, if you, I don't use Discord, so I'm just going to leave this. Additionally, you can help others with Discord. You'll earn karma that will help you earn fellowship achievements. Assignment, even though enough Discord talk, back to writing code. In Fantasy Quest, characters lose health due to heat exhaustion. The game tracks the temperature in freedom units, Fahrenheit. Yeah, okay, I get that one. America. But we need to display the temperature in Celsius for players outside the US. Here's the formula to calculate temperature in Celsius from Fahrenheit. Complete 2 Celsius function body. It should return the temperature of Celsius for a given Fahrenheit temperature F parameter. Okay. 2 Celsius. Copy that. Don't touch below this line, so we're going to return this. Easy peasy. It practically gave us the answer, but that's fine. Functions quiz. Reference the example functions and answer the questions. Function definitions. Definition. Calculate damage. Opening, attack, core damage, blah, blah, blah. Function definitions and function calls. Easy. Which keyword is used to create functions in Python? What's that? Func. Def. Which is not an alternative term for values that are passed into a function. Slots. A function must be defined to be called many times with different arguments. A function must be defined once to be called many times with different arguments. Solutions. Wait, skip. Kind of thinking through a lot of those. Okay. What's that Paul say? Okay, I just need to tell you about one last recourse you have when you're stuck. Every lesson on Boot.dev has an instructor solution you can view. No way, this button. I bet it's this button. No XP for that. Like Boot, solutions come at a cost, a steeper one in fact. If you view a solution before you complete the lesson, you lose all the XP for that lesson. Well, unless you use a seer stone, in which case you won't lose any XP. Though you will be down a seer stone. Just like it's free to use boots after a lesson is complete, viewing a solution after you complete the lesson is free as well. In fact, we encourage you to frequently check your work against ours. Oftentimes there's something to learn from the differences. View solutions sparingly. If you find yourself using a solution before completion more than about once per chapter, you should consider slowing down. Ask for help in Discord and even resetting the lessons to try them again and build a stronger foundation. Assignment. Enough about solution mechanics, let's write more code. We need to display the current time to our players. The problem is that time is stored as a number of hours, but we want to display it as a number of seconds. There are 60 seconds in a minute. How many are in an hour? Complete the hours to seconds function. It should convert hours to seconds and return the result. So don't touch any of this. So it's going to be hours to seconds. So we give hours in seconds equals, and then we're going to return hours in seconds. So hours in seconds. So hours in hours in minutes is like hours in minutes. It's going to be hours times 60, and then hours in seconds is going to be, hours in minutes times by 60 as well. I'm going to run that. Whoops, I screwed some up. Hours to seconds. Whoops, wrong. Hours. Whoops, hours in seconds. Good thing I ran the test thing. Okie doke, I'm pretty happy with that. Booshka. So it takes the hours times by 60, that gets the hours in minutes. And then once we have the hours in minutes, we times that by 60 again, because 60 seconds in every minute. Non-return. Non-return. When no return value is specified by a function, automatically return none. For example, maybe it's a function that prints some text to the console but doesn't explicitly return a value. The following code snippets all return the same value, none. Yep, return in blank, return none, and print with no return. What happens is if there's no return line in a function, the program crashes. It returns no values. An attempt to capture return value result in errors. It returns none. Alan Turing rolls over in his grave. Maybe, but not today. What's the difference between printing? What's the difference between printing a value and returning it? Print shows a value in the console. Returns makes a value available to the core of the function and shows it in the console. Oh. Print shows a value in the console. Return makes a value available to the core of the function. That one. Which guy? Multiple return values. A function can return more than one value by separating them with commas. So we're going to have definition cast, ice blast, damage is wizard level, blah blah blah, and all this return the two values. Receiving multiple values. When calling a function that returns multiple values, you can assign them into multiple variables, such as show. When cast ice blast is called, it returns two values. The first value is assigned to damage, second value is assigned to mana. Just like the function inputs, it's the order of the values that matters, not the variable names. Could easily call them 1 and 2. That said, descriptive variable names make your code easy to understand, so use them. The damage and new mana variables from cast ice blast's function body only exist inside the function. They can't be used outside the function. We'll explain that more later when we talk about scope. Assignment. Complete the become warrior function. Accepts two inputs, full name and the power integer. Should return two values, a title, a string, and a new power integer. Create the title using f strings, combine full name and warrior. So we're going to be create title. Title equals full name plus. Oh, you want to use f string. Sorry, was it f string? Yeah. So f and then full name. Whoops. Oh wait, no, sorry, I didn't put the closing one. Full name. Hold on, titles with the warrior in this format. Alright, okay. Full name the warrior. Clickety check. Create a new power value that is equal to input of power plus 1. So new underscore power equals power plus 1. Return both title and new power. So return title and new power. Divided below this line, run. Easy peas. Frodo Baggins. The warrior has a power level of 6. Bilbo Baggins, the warrior has a power of 11. Gareth the Grey, the warrior has a power of 8. Hey! That's over 9,000! Comment if you know that meme. You're from the 90s. Parameters versus arguments. Parameters are the names used for inputs when defining a function. Arguments are the values of the input supplied when a function is called. To reiterate, arguments are the actual values ouch, that go into the function, such as 42, the Dark Knight, true. Parameters are the names we use in the function's definition to refer to those values, which at the time of writing the function can be whatever we like. That said, this is all semantics, and frankly developers are really lazy with these definitions. You'll often hear words arguments or parameters used interchangeably. A and B are parameters. 5 and 6 are arguments. Yep, make that distinction. Are the values that are passed into the function by the caller. Arguments. Are the inputs specified by the function definition. Parameters. Alright. Good. Boy, we're only on chapter 3 still. Crikey. But we're almost at the end of this. If we can get to the end of this today. Yeah, we got time. We get to the end of this. Get to the end of this. Nobody's watching now, so I'm just going to end that poll. Never mind. Yeah. We got 22, 4 more of this, and then we got probably some time to go through scope, and then we end. I'm not going to go over too much tonight because I'm pretty tired from that long run. Got 40 minutes on the timer. Smash this. Default values. In Python, you can specify a default value for a function argument. It's nice for when a function has arguments that are optional. You, as the function definer, can specify a specific default value in case the caller doesn't provide one. A default value is created by using the assignment equals operator in the function signature. Yeah. If the second parameter is omitted, the default there will be used in its place. As you may have guessed, for this structure to work, optional arguments, the ones with defaults, must come after all required arguments. Complete get punched, get slashed functions. They should both take 2 integers as arguments, health and armor. Set armor to a default of 0. Get punched. So we'll do get punched first. Get punched, create a damage variable equal to 50 minus the armor. Hold on. So health and armor armor should set to be default of 0. So equals 0. Equals 0. So get punched. So create a damage variable equal to 50 damage equals 50 minus the armor. Minus the armor reduces the damage. Minus armor. And then create new health, new underscore health equals variable is equal to health minus damage. Minus damage. And return new health. Return new health. Get slashed. Create a damage variable. So damage equals 100 minus the armor. And then we want a new health underscore health equals variable equal to health minus damage. And then return. Oops, it is echoing type. Return new health. Let's run this. Whooshka. Archmage. Congratulations on making it to the end of the functions chapter. This is one of the hardest chapters in the Python course, though dictionaries are no walk in the park either. Really? Functions is one of the hardest? This what is one blah blah blah. Whoops. There we go. You probably figured out that chest contains gems and items. Gems can buy items in the shop. I have no idea. I've not seen like any of this. Where's the shop? I don't know. Boss, achievements, quests, shop. I don't have any gems. What the heck? I got no gems. XP items help you earn achievements and XP. XP levels you up, and higher levels unlock new roles. So why should you care about your role? My guess is that you've earned enough XP to be an apprentice by now. You can see your role at the top right of your screen. When you hit level 100, you unlock the final role. I am an apprentice. Archmage. It's kind of a big deal when you hit Archmage. You'll have learned a ton, built many real-world projects, and should be starting your job search. Unless I'm moving from where I am. You'll have unlocked all private role-based chat channels in our Discord. You'll have immeasurable bragging rights and a hoard of fake internet points. So valuable, so valuable. You'll get physical Archmage coin in the mail as a token of it. Oh, really? That's cute. Very nice touch. Which role is the highest in Boot.dev hierarchy? Archmage. Ooh, so we've got 2 challenges. An enemy's weapons can be cursed so that they don't deal as much damage. Assignment. Complete the course. The curse function. It accepts a weapon damage parameter and returns 2 values. The lesser curse damage reduce the input weapon damage from 100% to 50%. The greater curse damage reduce the input weapon damage from 100% to 25%. Alright, okay. A greater curse is more powerful than a lesser curse, so it reduces by more damage. So we're going to have lesser curse equals weapon damage divided by 2, and then only factor, and the way you can do it is times 0.5 greater cursed equals weapon damage times by 0.25. I run it. Whoops, I didn't even return anything. I'm done. Return. That's a cursed and greater cursed. Run it. Check it. Ship it. Shoot it. Bump it. Yeah. Easy. And the last one in this section before it goes on to the next thing. In Fantasy Quest, a weapon. In Fantasy Quest, a weapon can be enchanted to do bonus damage. Complete the enchant and attack function. It creates a new enchanted name for a weapon and calculates how much damage the enchanted weapon will deal to a targeted enemy. It accepts 3 parameters. Target health, damage, weapon. It should do the following things in the function body. Calculate and store the enchanted damage in a new variable. Enchanted damage should be the input damage plus 10. So we'll call this what was it? Enchanted let's call it damage equals what was it? Damage plus 10. Calculate and store the new health in a new variable. So new health equals in a new variable. The new health should be the input target health minus the enchanted damage. So target health minus enchanted damage. Create a new variable called enchanted weapon. Enchanted weapon should be the input weapon with the string enchanted added to the beginning of it, for example. Okay. So it'll be, we'll do it as F string and do enchanted weapon. Return the enchanted weapon and the new health for that order. So enchanted weapon and new health. Okay, we're in this. Happy days. Booshka. Nice. On to the next chapter. Here we go. We've got 30 minutes left, so we can get a decent... Oh! Hey, a line here. Hey, a line here. We smashed this one out. 4 chapters in one day. Ho ho. Boy oh boy. Here we go. Scope refers to where a variable or function name is available to be used. For example, when we create variables in a function, such as by giving names to our parameters, that data is not available outside of that function. Example. Subtract x and y. Result. Subtract x and y. Can't print x. Error. Name x is not defined. When the subtract function is called, we assign 5 to the variable x, but x only exists in the code within the subtract function. If we try to print x outside that function, then we won't get a result. In fact, we'll get a big fat error. Find the bug in the code 10. We're using variable names from the wrong scope. Fix it. I'll watch this video in a second. On line 10. Don't touch above this line, don't touch below it. Modifier. So it's my modifier and my level. Wait, I'll just watch this.
When you're learning Python, one of the most confusing things that can happen is you declare a variable, later you go to use it, and then Python complains that the variable was never defined. That's usually because you're mixing up your variable scope. Let's talk about it. Let's start with some code. I'm gonna kind of visually just draw out some code over here on the right side of the screen. So let's say we have a variable named x, and I'll just set x equal to 5. Now, this code is not within a function, so this variable x is going to exist within the global scope. And let me draw that global scope over here as a big box. Okay, so this is the global scope, and inside of it we have x is equal to 5. Global scope is pretty easy to understand. If any variable exists in the global scope, then it's going to be accessible everywhere within the program. In Python, scope is based on functions. So to get another example of a new scope, we need to define a function. Let's define a function f. We'll just name it f. And let's say that within f, we define a new variable called y, and we'll just set it equal to 10. All right, so we've indented now. We are inside of the function f, and we've created y. Well, y does not exist at the global layer. Instead, we're creating a new scope within the global scope. So this is the scope of f. And inside of that, we've created the variable y. So what this means is y is only accessible within the scope of f. Okay, so down here, I could, for example, print y, and that would work just fine because I'm still within the function f. What I could not do is come out here into the global scope and print y. This will break, right? Inside of the global scope, we do not have access to y. Y is only available within the blue box. But, interestingly, x is, right? We could here do print x, and this would work because x is in the parent scope, in the global scope, and so it still exists within f, if that makes sense. So you can move downwards, but you can't move upwards. You can go from parent scopes to child scopes, but you cannot go from child scopes to parent scopes. Let's do another example. Let's say we define another function g, and we define this function at the global level again. Okay, so I've dedented back to the same kind of level as x equals 5 and the f definition. And here we'll create a new variable called z and set it equal to 20. Okay, so where does this scope exist visually? I want to pause for just a second and let you think about it. So G does not exist within F. It's its own scope, but it does exist within the global scope. So G is going to be down here, and Z is a variable inside of G. So within G, we can access Z and X, but we cannot access Y. All right, one last example. We're going to define a function H, and we're going to define it within G. So let's do H here. And we'll create a new variable called A, set it equal to 1. Okay, now where is H going to live, right? H is going to live here inside of G. So within the H function, we can access A and Z and X, right? But we still can't access Y. And within G, we can still only access X and Z. We don't have access to A or Y. So the idea is pretty simple, and hopefully now you kind of understand the difference between a parent and a child scope and how they relate to each other. Now I want to show you a quick quirk about the Python programming language that isn't necessarily the same with other programming languages. Okay, so I've written some code here. We've got this function getNames, and inside of it I've created an array or a list of 4 strings, right? Lane, Alan, Bob, and Jill. And then we are going to loop over each name in the list and create a new variable called X and set it equal to name. And then we're just going to print out X once the loop terminates. Now I want you to look at this code and think, what's going to happen here, right? What is X going to print? Let's go ahead and run the code. This will be Python main.py. We got Jill, okay? So the interesting thing about Python is that even though X was declared within a for loop, X is still available outside of that for loop. And that's because in Python, variables are scoped to their functions, just like we covered kind of visually, right? It's important to note that in Python, variables are not scoped to blocks like for loops or if statements. Like they are in many other languages. In many other languages, this would throw an error and say X is not defined. I would need to say put the X in here, which would of course print it for every single one, or I might need to do something like declare X equals none up at the top, and then kind of overwrite the value within the loop. And the only other thing I'll say about this kind of weird quirk of Python is I wouldn't take advantage of it too much. It's a little weird, frankly. You know, as a developer who has had experience in more languages than just Python, to declare a variable within a block and then access it outside of that block, even though you're in the same function. So I would recommend not doing this very often, right? Even though Python allows you to do it, I think it results in kind of some weird to read code. I hope this video has helped you understand scope in Python and even scope in other languages a little bit better. If you found it useful, please do like and subscribe to the channel. It really helps us out.
I would if it was on YouTube, but we're not. Global scope. So far we've been working in the global scope. That means that when we define a variable or function, that name is accessible in every other place in a program, even within other functions. For example, this. Because pi is declared in the parent global scope, it is usable in getArea of circle function. Assignment. Let's change how we are calculating our players' stats. The only thing we should need to define globally is the character level, and then let our functions do the rest. Declare the variable player level at the top of the global scope and set it to 4. Bushka. Does getArea of circle function have access to the pi variable? Yes, because pi variable is in the global scope. Yes, because functions always have that one. Can the area variable inside the getArea of circle function be accessed outside the function? Can the area variable inside the function? Inside the function? No. Yes, because tomatoes are a fruit. Yes, all variables are accessible anywhere in the program. No variables inside a function are accessible outside of it. Bushka. Thank goodness we got to the end of that. We got at the end of 4 chapters, and this is kind of like the easiest thing of the whole bunch we're going to be doing and stuff. We've still got a bit of time. Still got 20 minutes. How many things are in here? 8. Oh, could we do 5 chapters in one day? That'd be ace. 5 chapters in one day. That is progress. That is progress, friends. Let's see. Let's make progress. Up until this point, all the coding lessons you've completed have been testing. I've been testing you based on your code's console output. What's printed, for example, a lesson might expect your code, in conjunction with the code we provide, to print something like armor 2, health 18. If your code prints that exact output, you pass. If it doesn't, you fail. A new type of lesson. Going forward, you'll encounter a new type of lesson, unit tests. A unit test is just an automated program that tests a small unit of code. Usually just a function or two. The editor will have the tabs main.py file containing your code, and the main test py file containing the unit tests. These new unit test style lessons will test your code's functionality rather than its output. Our tests will call functions in your code with different arguments and expect certain return values. If your code returns the correct values, you pass. If it doesn't, you fail. There are 2 reasons for this change. It's more realistic in the real world. You'll be writing unit tests and running them against your code to make sure it works as expected. You can run and debug your code with the print statements and leave those print statements in when you submit. Unlike the output-based lessons, you won't have to remove your print statements to pass. Assignment. Complete the total XP function. Accepts 2 integers as input. Level, XP to add. There are 100 XP per level. Total XP should convert the current level to XP. Then add this current XP to the XP to add argument and return the player's total, for example. Right. So, total XP should convert total. Whoops. There are 100 XP per level. Total XP should convert the current level to XP. There are 100 XP per level. So, level to XP equals level times 100. And then should convert the current level to XP, then add its current XP to the XP to add argument and return the player's total, for example. Pass keyword is a way to tell Python to do nothing. You'll need to replace with your own code. So then we'll return level to XP plus XP to add. Okay, run. And the test file has these run cases. So main test.py from main import. Okay. Run cases, submit cases equals run cases plus all these. Definition test. Main pass failed for blah blah blah. Submit. Whoops. That work? Oh yeah, I didn't see the confetti. Must have been a real thing. 2 lesson types. As we taught, there are 2 types of coding lessons in Boot.dev. I hate to get through. How long have we got? Oh, 17 minutes maybe. Console output lessons, unit test lessons. Console output lessons, only one file of code, usually with a comment explaining where to write your code. When you submit your code, its console output must match the expected output. exactly to pass. Debug print statements will cause your code to fail submission, so remove them before submitting unit tests lessons. 2 files of code, main and main test. You can read the tests, but you can't edit them. When you submit your code, the return values of your functions must match the expected values exactly to pass. Console output is ignored. You can leave debug print statements in your code. Which is more common. Going forward, you encounter far more unit test lessons than console output lessons, but you'll see both from time to time. Different concepts are best suited to different types of lessons. You can submit lessons with your debugging code unit. Happy days. Debugging. When you're working as a professional developer, you'll typically write code on your computer and test it by yourself before it's deployed to users. You might test their code. That first part of the process is called debugging. You write some code, run it, and if it doesn't work, you fix the bugs. You repeat this process until you're confident that your code works as expected. Run versus submit. At Boot.dev, the run button is for debugging. The submit button mimics the idea of publishing your code for production. You should use debugging your code by using the run button. You should be adding print statements in your code to make sure it's doing what you think it's doing at different points in the code. Write a line to calculate a value, print the value calculated, run the code, did it pretty much expected, if not, fix it, repeat. You will never lose XP or be penalized on Boot.dev for using the run button. However, there are consequences for submitting broken code, just like there are career consequences for pushing broken code to your users. The submit button will run additional tests. When you use the run button, a few tests will run against your code. However, submit button will run additional tests that you are not able to debug against. That's what keeps it fun and realistic. It's hard to know what your users will do with your code. Assignment. Complete the take magic damage function. It should return the new health after calculating how much magic type damage the player takes. Here's a description of the arguments. So health, the player's starting health. Resist, the player's magic resistance. This reduces the damage they take by a static amount. Amp, the attacker's magic amplification. This increases the damage they deal by a multiplier. Spell power, the base damage of the spell. First, calculate the total maximum damage to be inflicted by multiplying total. Let's call maximum. Damage equals total maximum damage equals spell power times the amp. Then subtract the resist from the total damage to get the actual damage dealt. Actual damage dealt equals actual damage dealt. So it's going to be total maximum damage minus the resist. Apply the damage to the health player's health and return the new health. So return health minus actual damage dealt. Run it and submit. Boom. Oh yes, 4 more lessons. I think we can do it. I think we can do it today, especially if they're easy things like this. Hold on, my phone went on to do not disturb mode. It's fine. We'll keep an eye on it. We'll get to the end of this and then we'll just stop. This course is about to get a bit harder. There's no way around it. If programming were walking block, everyone would be earning 6 figures as a software engineer, but it's not. And to succeed without getting stuck and frustrated, you'll need to learn how to learn. Process for solving hard coding problems. That's interesting. Read the lesson first. Figure out the examples before writing your own code. Read the assignment. Understand the goal of the assignment before you start writing code. Start writing code. Add print statements. Don't wait until you've written a lot of code to start testing. Add print statements and use run button to see if your code is doing what you expect at each step. It's easy to find issues in small bits of code than in large blocks of code. Keep running, printing, and fixing until you're confident your code is working. Submit your code. If the assessment you're working on has unit tests, no need to remove your debugging print statements. If the assignment you're working on is testing console output, be sure to remove your print statements before submitting. Compare your code to instructions. You will not be penalized if looking at a solution after you can successfully complete the assignment. Additional tidbit. Peek at solutions. Try Boots before peeking at solutions is quite good at giving you points. It's okay to peek at the solution and completely stuck every once in a while, but don't make it a habit. You can reset your code. You can reset all your cache code, blah, 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 blah. Yeah, I know that. You will be penalized for peeking at the solution after you successfully complete an assignment. Nope. Yeah, I've already done this one. Temporarily adding print statements is a good way to quickly test and debug small piece of your code. Lose some XP, get carpal tunnel syndrome. Nice. Some more questions. When you're stuck, which should you do first? Whine on Twitter about how hard coding is. Oh, doesn't everybody do that? Like day to day. I think it's no different to anyone. Peek at the solution. Ask Boots a question about your code. I definitely got to whine. No, ask Boots. He's a good guy. He's a good bear. Debugging practice. I want to walk you through how I approach writing code. Complete all the debugging steps I take along the way. The goal is to write small amounts of code and test each bit of code to make sure it's doing as we expect before moving on. Trying to write an entire program at once is a recipe for pain and suffering. The goal is to write a few lines, test them, and then write a few more lines, and repeat until you're done. This isn't a technique that's unique to beginners. Even senior engineers code this way. Do we? Yeah, we do. Let's complete the unlock achievement function. Accepts 3 arguments: before XP, XP, name. So it'd be like achievement. It's achievement, XP, achievement name. It should return 2 values: the player's XP after the achievement unlocked, the sum. Let's players XP. Let's players new XP, which is before XP plus XP. An alert message that says should return 2 values. An alert message that says achievement unlocked, achievement name, where the achievement name is the name of the achievement. Alert underscore message equals we'll do f string. I'm getting used to that. In fact, I'll just copy it because I'm lazy. Achievement unlocked, and then we swap that for name. Let's start by running the code in its current state. You should see an error like this: indentation error. Looks like we're getting a syntax error. Python doesn't allow you to have an empty function body. To get past this error, let's just return 2 dummy values from the function, return none and none. With the code again, this time you shouldn't get a syntax error, but your test should fail because you return incorrect values. Let's fix that. Let's start by calculating the new amount of XP. After XP, update the body function with the code again. This time we should see the after XP value printed to the console. Does it look correct? It shouldn't. We have a bug. The after XP should be the sum of the before XP and the achievement XP values. To fix the code, we run it again, make sure it's all working. Once that's working, remove the print. Remove the print statement and return the after XP value instead of the first none. Run the code again. You should see your tests are close to the first expected, and the actual value should match for each test. The second return value is still broken. Let's fix it after XP. So achievement and the achievement name. Looks like the output is missing the word unlocked. Fix the bug. When you're confident, remove the print and blah de blah. So player new XP and alert message. Run that. Passed it. Let's submit it. But yeah, we're almost at the end of this, so we're going to finish this, and that'll be like where we finish for today. That'll be a nice stopping point. Because we've got 7 minutes left, but I'm not going to stay on that long. Not today. My phone is saying it's Betty Bow time. Checking some on my phone. Disturb. Okay. Stack trace, last one for today, and then we completed this module, and next time we'll be on computing and all sorts of lovely goody gumdrop stuff. Awesome. A stack trace or traceback is a scary looking error message that Python interpreter prints to the console when it encounters certain problems. Stack traces are most common, or at least for you right now, when you're trying to run invalid Python code. You need to get used to figuring out scary error messages as a programmer. We might as well start now. The assignment. Go and hit the run code button, and the current statement you should see something like this. Python error, traceback, most recent call last. This is a standard head that's just letting us know that Python traceback is what we're looking at. File exec line 6 in module and file string line 1 in module. This is the start of the trace. These strange exec and string files don't really exist. The Python interpreter is letting us know about them because they have to do with how our code is executed in a virtual browser-based environment. File home pyodide main py.line3. Now we're getting to the real meat of the error message. The purpose of a trace is to show us the path that the Python interpreter took for our code before it encountered the error, which can help us figure out what went wrong. In this case, the interpreter was executing the code main py file, and it got to line 3 before it encountered the error message. Like this part, okay? This is the line code that caused the error. Indentation. Unindent does not match any outer indentation level. I think it's just the fact that there's a missing quote. This is the type error that was raised. In this case, it's an indentation error, which means that Python interpreter expecting a certain amount of indentation, white space at the beginning of the line, but it didn't get what it was expecting. Don't be fooled. The proper amount of indentation in Python 4 is spaces, or one tab stroke. In this case, line 2 is actually indented 6 space. Line 2 is indented 6 spaces. Fix line 2. Run the code again and see if there's another error this time, something like this. Unterminate string literal. Now I have a syntax is more general type error, valid code, take a look closer, I've been fixed. So it's just the fact that there's a missing quote at the end. Bingo. Hey. Wow. And there we are. We're on to chapter 6 of this Python one. How do I kind of go to the home screen, log out? I don't want to do that. Recruit a friend. I just leave on this, I guess, but I'll go back to courses. Yeah, nice. So I can see like this one's where it's at. I don't want to restart. So I go back in, just come back to straight to where I was before. Awesome. God, what a night. Well, sorry for starting late, peeps. It was just I had a longer run than usual. That was a bit of a tough one. It was really misty and miserable out there as well. It's cold, so that wasn't fun. But we got stuck into this. I'm enjoying it so far. This is obviously very, very beginner level, and I'm not a beginner. It says flexing the coding skills, but yeah, we're getting started. It's a beginning thing and stuff like that. So like we get through this. Tomorrow we're going to be back. That functions like one of those. I think it was functions was quite a long like section. So hopefully some of the sections a little bit shorter. I say shorter, just like, you know. I think if we get this one out, this course out of the way, and we start getting on to the next thing, because there's how many courses are there in total? It's 24. So if I did 2 courses a month, I would get through. I get through this within the year. So if we could do more than, hold on, I miscalculated that. 24. Yeah. So if I got through like one a week, yeah, well, I'd definitely get through it all. But I'm not going to get through, I think, a course per week. I think it's going to be, it might be a little bit longer. And there's like deeper learning courses after that. So like, but we'll see. Yeah. So we'll leave it there. So we'll be back tomorrow. It'll just be day 2. We're just carrying on with the Python section, and we'll crack through this. Yeah, I want to get through these, and depending on how the progress we make early on, I'm going to like switch up the streams from like this to maybe doing starting the some of the projects I want to do. We'll go from there. Awesome. Thanks so much for coming along. Adios. Have a good night.